3B in the exercise questions to show the number 3.25 in 8-bit floating point representation. So again, I've left the 4 points up that the 4 steps we need to follow. So step number 1, we need to convert the number. So we take the 3, okay, and again using our numbers before, which are 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. Okay, so we're taking our number 3, and our number 3 will convert to 1, 1. Fantastic. So then what we want to do is we want to take our fraction bit, so our 0.2, so the way I do it, 0.25 times 2 gives us 0.5. Okay, we're going to use these bits, but it's not 1. So we'll take this number here and we'll bring it over here. 0.5 times 2 is 1. So we've got 1 here. We'll take this 0, we'll take it over here. 0 times 2 is 0. So what we'll do is we'll use these numbers here, reading them in this direction. So that gives us the number 0, 1, 0. Okay, so we can then safely say that 3.25 is equivalent to 1, 1, 0, 1. We don't need that last 0 there. Okay, and that's with the point in here. What we need to do is, so that was step number 1. Step number 2, shift the dot. We have to represent it in scientific notation. So shift the dot. We've already explained the right hand rule. So if we move the dot to the left, the exponent goes up. Yeah. So if we move to the left hand side, the exponent goes up. Alternatively, if we move to the right hand side, the exponent goes down. So in this case, we're moving the dot up, and to make it between 1 and 10, we're only needing to move it 1 point. So we can say that 1.012 is the same as 1, moving our dot up, 1.101 times 2. We've moved it 1 point to the 1. Okay, so we're building up our number here. We know it's a positive number, so we know our most significant bit is going to be 0 for a positive number. Okay, we know now that our exponent is going to be calculated now. So our exponent is the bias plus p. We've moved p up, so we know that p is equal to 1. Okay, so our exponent for single precision is 127, and we know that p is 1. Okay, and that gives us 128, and that's to base 10. We can translate that, put it into binary by saying that it would be 1, 0, 0, 0, 0, 0, 0, 0. So now we've got our exponent. Fantastic. Now what we need to do, part 4, put it all together. So we need our most significant bit, which is 0, our exponent, which is 1, 0, 0, 0, 0, 0, 0, and we need our mantissa, which is the floating point part of our number. So in this case it's 1, 0, 1, and then we 0 pack it till we get to our 32 bits. So it's 20 zeros. So The number we're looking for is 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, all zeros.